Okay, let's take a quick look at lesson 5 here, determining a quadratic function in vertex form. So we're looking at our y equals a x minus p squared plus q form. And what I want to be able to do is I want to be able to look at a graph and take the information from the graph and complete this equation, the function. Come up with the function for that graph. So what I want to do here is I know right away, the first thing I think that I would like to find is my vertex, which is of course p comma q. And if I can look at those values, that's a -3, 0. So I know that p and q in my vertex are my vertex, and p and q, those go into the formula. So that's just another word for x and y, but because it's p and q, it's this, we know it's specifically the points x and y for a vertex. Okay, so y equals a x minus -3 squared plus 0. So I know that -3, p is -3, p is the actual value on the graph, right? P is the -3, and when I put in a -3, because it's minus a -3, we get an x plus 3 all squared. And the 0 is no longer there because adding 0 is kind of irrelevant. So what I want to do now is I need to find the a value. Okay, let's do that algebraically to start with. So what I need is, in order to solve for an unknown, I can't have 3 unknowns in an equation to solve for one. So I always would have to find another point. Okay, so let's go back here. Let's choose one of the points that is given to us. We know this is -5, -2. -5, -2. So that's my x and my y value. I'm just going to plug those in. -2 is equal to a -5 plus 3 all squared. And of course we get -2 is equal to, no, this is just multiply. This is a times. So this is just like saying if I have a4, that's the same as 4a. I know that's multiply. And this is multiply, same thing here. So this is -5 plus 3, which is -2 all squared. So this is a times 4, or 4a. And we're going to divide both sides by 4. And we're going to solve and get a is -1/2. Okay? And now that I know that a is -1/2, I've got my equation. Y equals -1/2 x plus 3 all squared. Okay? So the p and q we get from looking at the vertex, and the a we have to solve for. Now another way to solve for a, if you understand the pattern of the parabola, once we look at that vertex, I know that regularly I would go over 1, down 1. I've definitely not gone down 1 because you can see that the number is not on the grid, or the point is not on the grid. And normally we would go over 2, down 4, which would be right here. So instead of going 4, we've only gone 2. So 4 times a half is 2. We've gone half the distance. So therefore I know that a is going to be -1/2 for 2 reasons. One, because it's half the distance, and negative because the parabola is opening down. So that's another way to look at this kind of question. We do still have to be able to solve for an algebraic equation, an algebraic approach, and because sometimes you'll get a stretch value of 2/3 or something strange like that. So we still do need to be able to do the algebra. Okay, let's do one more example like that. If I look at 2, 1, right? There's my vertex. So I'm going to start with that y equals a x minus 2 squared plus 1. And I'm going to choose one other point on the graph. I'm going to choose 1, 5. And we get 5 is equal to a 1 minus 2 squared plus 1. So I get 1a, right? 1 minus 2 is -1. -1 squared is 1. So we get a times 1 plus 1. Now this is not a times 1 plus 1. This is not 2a plus 1. Sometimes students think that this gets added. Well, of course that can't be, because we know bed mass. Okay, we know that we need to multiply before we add. So definitely not going to do that. And now, of course, we've got, this is just the same as a plus 1, right? Subtract 1 from both sides, and 4 is equal to a. A is equal to 4. And by looking at the graph, we can tell it as well. Instead of going over 1 up 1, we're going over 1 up 4. So we know that 1 times 4 is 4. Our vertical stretch is 4. So our final equation here is y is equal to 4x minus 2 squared plus 1. Okay, let's take a look at the next question. It says, suppose a parabolic archway has a width of 280 centimeters and a height of 216 centimeters as its highest point above the floor. So it's like a tunnel. Okay, this is like a tunnel. Write a quadratic function in vertex form that models the shape of this archway. So what we want to do is we want to use our our vertex formula, and I'm just going to use this parabolic kind of shape to create a grid right on there. So there's a couple ways we can do that, and one way to do that is to create sort of an x and y axis right here. This would be our x-axis, and there would be a y-axis. This would definitely be an excellence type question on an exam, so as long as you can understand and follow along, that's just totally fine. We're going to use the information that we have. So what I want to do is figure out, first of all, what would my vertex be? If this was, of course, my origin right here at 0, 0, what would my vertex be? If the whole width of this archway is 280 centimeters, then 280 divided by 2 would be 140. So the distance here would be 140. Okay. And the height is, of course, 216. So there's my vertex of my parabola. So if I start with my y equals a, x minus 140 squared plus 216, that's the first step in finding my equation. Now I need one other point on the graph, and I can either use the origin here, or I could use this other point, which would be 280, 0, right? And I can tell that because let me just erase this here. I can tell that because, of course, this is 280 over, and it's on the x-axis that we've kind of designated as a x-axis, so there's my y value is 0. So I can use either of those two values, 0, 0, or 280, 0. So 0 is really easy to use. So I'm going to use my vertex, which was 140 and 216, and a point 0, 0. So if I plug in 0, 0, I get 0 is equal to a 0 minus 140 squared plus 216. And I'm just going to take my calculator. I'm going to, subtract the 216 first of all. And I get a equals 140, negative 140 all squared is 19,600. And then if I, of course, divide both sides by that, that's a positive 19,600. We end up with an a value that is negative, and I believe we get a is negative 27 over 2450. How did I get that? I math fraction that. So let's just go into our calculator. And if you have your calculator handy, you're just going to clear, and we're going to plug in 216 negative divided by 19,600. And if you've got your graphing calculator, you're just going to push math fraction. Oops, it should work. Maybe it's not working nicely. It should work on a graphing calculator. If it's not working, then it might be just too hard of a number to work. But if I do 216 divided by 27, I believe my common divisor is 8. So 216 divided by 8 is 27, and 19,600 divided by 8 is 2450. So there's my reduced fraction. I guess I had to figure it out instead of using the math fraction. Hopefully that works on the TI. I think it should. Anyway, so our final a value is that. And then what would our final equation be? Our final equation would be y equals negative 27 over 2450 x minus, and let me just cut this and move this over a little bit. Okay, and we've got this vertex here. I'm just going to cut that and move that over. There we go. And we get y equals negative 27 over 2450 x minus 140 squared plus 216. So there's our final equation for that parabola. Then it says determine the height of the archway at a point that is 50 centimeters from its outer edge. So if I want to go 50 centimeters from the outer edge, that means I'm looking at a value here of either 50 or a value here of 230. And how am I getting that? I'm moving 50 in from 0, that's 50, or 50 back from 280. So 280 minus 50, right? 280 minus 50 is 230. So if my x value is 50 or my x value is 230, I can use either of those. So x is 50 or x is 230. And if we plug that into our equation, 50 minus 140 all squared plus 216, we should get a value of approximately, I believe it's approximately 126.7 when I plug that into my calculator. Okay, so plug that in, go through, do the math, and of course you're subtracting, squaring, multiplying. If you plug it in that order with your graphic calculator, you should get 126.7 centimeters. Okay, so that's the height of this little archway. Okay. Okay, for this next question, what we want to do is we want to go through and apply these transformations. It says, we start with the graph of y equals x squared. And it says, first off, we're going to do a reflection in the x-axis. So reflection in the x-axis means if our y equals x squared was opening upwards, our x-axis is the mirror. It is now opening downwards, so a is less than 0. Our a value is then negative. So it says, find the equation of the image function after the transformation. So I know that my a value is going to be negative. And then it says a vertical stretch by a factor of 1/3. And if it's stretching by a factor of 1/3, it's kind of that squishing down effect, isn't it? If it's a value greater than 1, it would get really skinny. Okay, a is greater than 1. Or if it's an a value less than 1, some kind of a fraction, our graph kind of widens out. Okay, and so we're going to say y equals negative 1/3. Okay, there's our a value. And then translation 7 units to the right. So p is 7. And p is going to be our left rightness, and 7 units to the right means p is positive 7. And of course, in our equation, when we put in a positive, it's x minus positive 7 squared. And no mention of up or down, so q is 0. Okay, q is equal to 0. And this 1/3 was our a value as well. Okay, so there's the equation, and we don't always write plus, negative, minus a positive. So we often will just see this like this, right? X minus 7 squared. And we know then that our vertex would be 7, 0. Oh, and that's the next question. Vertex is 7, 0. Then it says find the value of t. So if I want to find the value of t, when at the end of the 3 transformations, it says the point 1, t is on the resulting graph. So let's go back to our equation for a second. Negative 1/3 x minus 7 all squared. I know I have some point 1, t on my graph somewhere is what that's saying. And this is x and this is y. So I want to sub in, instead of y, I'm solving for t. Negative 1/3. 1 minus 7 all squared, and then of course t is simply negative 1/3 times negative 6 squared, which is 36, and 1/3 of 36 negative, that's negative 12. So t is negative 12. Okay, and then the last type of question you might be asked to do in this section here is if you're given a vertex and a point without a graph. So sometimes you don't have a graph, you can't look at to find the a value, but we can look at this and just use the equation. So if this is our vertex, there's our PQ, and here's our XY. I'm going to start with my equation, x minus p squared plus q, and I'm going to plug in negative 24, x is 7, p is 3, and q is 8. So I'm just solving for a. I'm going to subtract 8 from both sides, or in other words, we're going to move over the way 8. And we end up here with a negative 24 minus 8, which is negative 32. And then 7 minus 3, that's 4, and 4 squared is 16. So a times 16. Okay, I can write like that, or we could write, of course, 16a equals negative 32. And then it's pretty obvious. We divide both sides by 16, and a is equal to negative 2. So our equation, when they ask for the equation, I want to write out the final equation. X minus 3 squared plus 8. Okay. Algebraically determine the x-intercepts for the quadratic function above. So if I'm looking for the x-intercepts, I let y equal to 0, and I go 0 is equal to negative 2, x minus 3 squared plus 8. So I'm doing BEDMAS backwards because I'm, of course, isolating the x here, right? If we were just solving an expression, we would go ahead and we would use our BEDMAS rules if we're simplifying. But because I'm stripping down for x, I have to do the opposite. So instead of BEDMAS, we're doing SAM, DEB is the order we're looking at. So the first thing we want to do is find, is there any addition or subtraction here? Of course, I want to subtract 8 here. So 0 minus 8 is negative 8. And now I want to divide both sides by negative 2. So we get a positive 4. And of course, I want to take the square root of both sides, but we remember that little trick. When I take the square root, there actually could be 2 numbers squared that can give me 4. So I have to take the plus or minus the square root of 4. We get 2 is equal to x minus 3. Sorry, plus or minus 2. And of course, when I move over the minus 3, that's a positive 3. So x is 3 plus or minus 2. X is equal to 5, or x is equal to 1. Right? 3 plus 2 and 3 minus 2. So my two x-intercepts are 5, 0 and 1, 0. And there we have it. Okay. Let's just pause and have a look at this. Well, why don't we have a look at this? What's this one? A parabolic highway tunnel. We may as well do this one too. Why not? Sketched below has a cross section given by x squared plus y minus 16 equals 0. So a cross section is just as if you were cutting this parabola right along the purple there. Right, there's our cross section. And of course, there's an equation. It's a parabola. It's kind of written in a strange form. We could rewrite this, right? We could rewrite this, and we're going to do that right away here. So it says the maximum height, y is positive, x and y are measured in meters. The maximum height of a 3-meter wide truck traveling through the tunnel in the right-hand lane cannot be greater than. So if this is a tunnel and there's a truck going through it, here's the truck, right? What's the maximum height that this truck can be if it's 3 meters wide? So that means our x value here would be 3 or negative 3. And actually, I guess the whole truck, if it's going in the right lane, then it would be the positive 3, I guess, right? So x is equal to 3. Okay, if our truck is 3 meters wide, what's the max height that truck can be? So I'm just going to plug in and solve for my y value. So our equation is x squared plus y minus 16 equals 0. So I'm just going to isolate the y, moving over everything else, and we get y equals negative x squared, right? When we move something over, it becomes negative, or if it was negative, it becomes positive. So y equals negative x squared plus 16. So y is equal to negative 3 squared, okay? And it's just the 3 that is squared. So y is equal to negative 9 plus 16, right? Because the negative is in the equation, so I don't square the negative out. And so y is equal to 7. So the maximum height of that truck would be 7. Okay, I don't know if we did that one in class. So if we do this one now, it's bonus math. Okay, Good luck, and hopefully you've had enough, this makes enough sense to be able to do the questions in the assignment book. Thank you.